Welcome everyone. Today we are going to discuss the 8th unit of our course material, Standard Progression Analysis and Wastage Reduction in EDA 844, Educational Statistics for Education Manager. From this table, we are required to calculate the progression ratio and present our answers in a table, and to determine the standard progression ratio and present our answer in a table as well. We added the two other questions there in case for any reason whatsoever we are asked to determine the actual input. I think that is actually in one of the question papers anyway, and then to calculate the wastage ratio. So we are going to do all these in this presentation, so kindly pay attention so you get the detail of our discussion. All right, here we have the table. Before we continue, I would like to point out that there are actually some errors on this table. For instance, you can sum up the first row here. You'll notice that it will not be equal to the results here. It's actually like that on some other rows on this table. That notwithstanding, we can calculate our progression ratio, standard progression ratio, and the other questions we raised earlier. So in calculating the progression ratio, this is what we need. The formula k raised to the power of t sub g is equal to e raised to the power of t plus 1 sub g plus 1 over e raised to the power of t sub g. Now let me quickly explain this. Here k simply means the progression ratio. T is the year considered. It may be year 2010 as we have here, and then the G is a grade, that is this grade, the grade we have here, 1 2 3 4 5 6. Then e raised to the power of t plus 1 simply means the year after the year considered. The year after the year considered. If we are talking about 2010 now, it means this very year 2011. E raised to the power of t plus 1 will mean 2011. That is 2010 plus 1, which means 2011. Then G plus 1 here simply means grades 1, for instance, plus 1 will give us grades 2. So if we are talking about the progression ratio of students or pupils from grade 1 to grade 2 now, the grades concerned here is 1. Then they are progressing to grade 2. They are progressing to grade 2. So the progression ratio now will be the number of students that progress to year 2 over the number of students in the previous year. You understand? And then we multiply the results by 100 if we are to get our answer in percentage. So take note of that. Now let's quickly move on. Now to calculate the progression ratio, let's take this for instance, the first year. Now we are talking about progression ratio of from grade 1 to grade 2. Grade 1 is 2010 now, to grade 2 2011. So we simply employ the formula grade 1 2010 to grade 2 2011 will give us the number of students or pupils in grade 2 2011, which is 11,363, over the number of students in the previous year. Number of students in the previous year, that is 19,796. Then multiply the results by 100. We'll have 57.4%. So that is the progression ratio from grade 1 to grade 2. Now let's take another example. For instance, okay, grade 5 to grade 6, 2010 to 2011 as well. So what we need to do is employ the formula grade 5 2010 to grade 2 grade 6 2011. We have the number of students progressed to year 6 2011, that is 86,791. Then divide it by the number of students in the previous year, that is grade 5, the previous year, 98,349. And when we multiply the result by 100, we're going to have 88.2%. That is for that. We can take another example. Grade 1 2015 to grade 2 2016. So all we need to do is employ the formula number of students in grade 2 2016 now 11,844. We divide it by the number of students in the previous year. Remember, in grade 1 previous year we have 12,180, and when we multiply the result, we're going to have 97.2% approximately. Let's take one more. And okay, we have grade 4 2014, yes, grade 4 2014 going to grade 6, grade 5 2015. So we employ the formula grade 4 2014 to grade 5 2015. So we have the number of students in grade 5 2015 over the number of students in grade 4 2014, that is the previous year. Multiply the result by 100 and we're going to have 81.4 approximately, 81.4% approximately. This is how to calculate the progression ratio. We divide the number of students in a particular year by the number of students in the previous year and multiply the results by 100, and then we have our answer in percentage. Now let's see how a table will look like when we put it on the table. The results we're going to have here on the table. Our table will take this form: 2010 to 2011, grade 1 to grade 2, we have 57.4. That was what we got when we calculated the progression ratio from grade 1 to grade 2. When you do that to other classes, we are going to have all these. The ones we did together, those ones I circled here, you can see that here. 1, 2, 3, 4. You can pause and then do the other calculations, cross-check what we've done to see that they are actually correctly written here. Please, you can do that now. Pause the video. Try to calculate the progression ratio. I give you the clue again: calculating the progression ratio from grade 2, for instance, to grade 3, that is 2010 to 2011 now, will be the number of students in grade 3 2011 over the number of students in grade 2 2010, multiply the results by 100, and we'll have this answer, approximately 99.0%. Do that. I'm waiting for you. Please, you can post your answer on the group page so that we can all see how you did your work. All right, having done that, let's quickly see how we can calculate the standard progression ratio. So to calculate the standard progression ratio is quite easy. All we need to do is sum up all these columns from grade 1 to grade 2, for instance. We'll sum up everything: 57.4 plus 96.5 plus 96.8 plus 97.5 plus 97.5 plus 97.2. We're going to have 542.9. Then divide the results by 6. Divide the sum by 6, and we are going to have 90.48%, or 0.9048 in decimal. You may be wondering how we have this answer in decimal. All what we did is just to divide the result here by 100. You remember we multiplied it by 100 to get these results in percentage. Then now if we want to convert it back to decimal, we simply divide it by 100 and we'll get these results in decimal. So you can try that for grade 2 to grade 3, 99.0 plus 98.9 plus 98.9 plus 99.2 plus 99.2 plus 98.9, and we're going to have we're going to have 594.1, and when we divide it by 6, we're going to have 99.02, and in decimal, remember, divided by 100, and we're going to have 0.9902. You can do that with all this stuff to confirm the answer we have here, to see that they are correctly done. You can pause the video, check this to show that you are actually following. All right, thank you. Let's see. Okay, let's see how we can calculate the actual inputs and the actual outputs. Now we are going to apply the standard progression ratio to a population of 1,000. You can do that with a population of 2,000 or anything of your choice, any number of your choice, but we are going to do that with a population of 1,000 here, and this is how we have to do it. Now we have the standard progression ratio here. Remember that we have the percentage form and we have the decimal form here. We are going to use decimal form, but if you want to use the percentage form, remember to divide your results by 100. Remember to divide your results by 100 anytime you do that. It's the same with using the decimal directly, because we've done the division here already, so it's just to apply. So what we're going to do here is we're going to work with the population of 1,000, as we said earlier. We have it this is year T, say grade 1 year T. We have a total of 1,000 pupils in grade 1. Now the progression ratio from grade 1 to grade 2, that is T plus 1 now, is 0.9048. So what we are going to do is simply multiply the 1000 by 0.9048, and we're going to have it as 904, that is 904.80 approximately. So if we recall that since we are talking of human beings, we can't have a decimal, so we have to approximate our answer, and this will give us approximately 905 pupils. 905 pupils. And now, progression from grade 2 to grade 3, that is this is supposed to be year 3. Take note of this, is year 3, that is year T plus 2, that is year 3. So recall that we have 2 to 3, the ratio is 0.9902. So we have 905. So we are going to multiply 905 times 0.9902. And we have this 896.13, approximately 896 pupils are now in year 3. Now, grade 4 now. Remember, grade 3 going to grade 4, we have 0.9900 as the progression ratio. So grade 3 going to grade 4, we have a number of those in grade 3 already, 896, and when we multiply it by the ratio, we're going to have 887.04, and this will give us approximately 887. That is done. Now we have grade 4 to grade 5, that is those in grade 5 now. Recall that the progression ratio from grade 4 to grade 5 is 0.8823. So we have number of students in grade 4 going to grade 5 multiplied by the progression ratio, and we have 782.60, approximately 783 pupils will be in grade 5. Now we have the progression ratio from grade 5 to grade 6 put as at 0.9168, and since the number of students already in grade 5 is 783, for us to know those going to year 6, we have 783 multiplied by the progression ratio, and that will give us 717.85, and that is approximately 718. That is to say, the total input now will be equal to the sum of all these, 1000 plus 905 plus 896 plus 887 plus 783 plus 718, and this will give 5189. This is the actual input. The actual output is this, that is the total output, the number of those that are going to graduate from grade 6. They are the total output. I believe this is clear. If it is not clear, please, you can backward your video as many times as possible to see that is quite clear to you before you move on. All right, let us complete our discussion by discussing the wastage ratio. To calculate the wastage ratio, we need the total input and the total output. We've seen from the previous slide that the total input is 5,189 and the total output is 718. Now, we also need to calculate the input-output ratio. And the input-output ratio is the ratio of the input to the output. So from here, we've seen that the input is 5,189 and the output is 718. All we need to do is to plug the results here, 5,189 over 718. And when we do this, we're going to have 7.23. All right. Also, we need to know the ideal input-output ratio. You recall that the ideal input-output ratio is 6/1. That is the 6 year that is required to produce a student, a pupil in a primary school. Remember, we need 6 years to produce one pupil in primary school. So it means the total input of this pupil will be 6 over the number of pupils that will graduate will be 1. And that is why we have input-output ratio. The ideal input-output ratio is to be 6. It can be 7 in case of repetition, and so we may have it 7, 8 or whatever, but the ideal is 6. Take note of that. So for us to know the wastage ratio, all we are to do is actual input output ratio over the ideal input output ratio. Actual input output ratio over ideal input output ratio. I take that again. Actual input output ratio over the ideal input output ratio, and that will give us the wastage ratio. If we do that, we know that the actual input output ratio is 7.23 over the ideal input output ratio is 6. So we do that, we're going to have 1.205. This shows that it is a moderate efficient institution. To have something like this is moderately efficient. So thanks for watching Maths Guru's video. Please don't forget to subscribe. Recommend our videos to your fellow students so they can also benefit from this service. Thank you. We love you, and we always do our best to produce what will enhance our performance in examination and in our various places of services. Thank you. Bless you.